In this, we are learning about digital registers. Let us know about what is digital register. Digital register is a element which is used to store our data in digital format. Uh, Binary data storage. A register comprises a group of flip-flops collectively storage multiple bits of binary data, which individual flip-flop is capable of storing a single bit, either 0 or 1. N bit of word capacity. It can store up to n bits, like number of bits. An n bit register is specially designed to store of n bit digital word. This modular structure allows the flexibility data representation and handling, data storage and movement. Register serves to do critical functions within digital systems efficiently. Efficiently, data storage and seamless data movement, acting as a vital intermediate in data processing. In digital registers, flip-flops are the main base to the registers. Flip-flops are fundamental bistable electronic devices, meaning they can exist one to two stable states representing a single bit of data, 0 or 1. They are the memory core of digital systems, holding their state until a control signal dictates a change. This ability to remember a bit makes them indispensable for registers. There are three types of registers which are D flip-flop. Uh, a simple data latch storing the input D when clocked. JK flip-flop. A versatile type of set with J and clear K inputs, offering more complex control. SR latch, a basic set reset latch, often asynchronous. Register integrate multiple flip-flops or all synchronized by a common clock signal to ensure coordinated data operations. Let's know about basic register operation. Uh, there are three cases. We are considering a first cases clock synchronized loading. Data is loaded into register during specified clock pulses, ensuring precise timing for all operations within the digital circuit. When the clock pulse is one, the circuit becomes on and it will operate. Either it will D flip flop or SR or any kind of flip flops. When the clock pulse is one, the circuit will be on and it will do operations and control data updates. The second case is control data updates. Control signals such as load or enable are used to dictate when data can be updated, preventing unwanted changes and maintaining data integrity. This control signal is used to control the register, whether the operation will be on and operation will be off. If the control signal is off, the operation cannot be happen. The previous output is as same as the present output also. When the control signal is on, you can edit or you can rewrite the data. You can rewrite the data from past value and given future value. And the third one is avoiding timing issues. While clock gating can manage data flow, it sometimes introduces time problems. A more robust solution is a load control feedback, ensuring reliable data updates without glitches. Register is also classified as shift registers. That means moving bit by bit to left or right. Either it will be left register or right register. If it is a right register, the bits are moved to right by a serial. If it is left register, the bits are moving towards left by a serial case. Shift registers are specified typically on digital register capable of moving storage bit either left or right as it earlier as each clock pulse. When a clock pulse is applied, the bit will be moved to next flip flop. Either it will be left or right. Serial to parallel conversion. Conversion of a stream of serial data into a parallel format using for processing. Parallel to serial conversion. There are two types of conversions in this shift registers. One is serial to parallel conversion, another is parallel to serial conversion. Parallel to serial conversion transform parallel data into a serial stream to efficient transmission. These registers are crucial for applications requiring data delay. Specific arithmetic operations like multiplication, division by powers of 2, and serialization of data for transmission over signal lines. There are types of registers. Shift register comes into various configurations, each suited for different data handling needs. These type of dictate how data enters and exits the registers from serial streams to parallel blocks. The first one is serial input, serial in, serial out. It means the data will be entered into the flip-flops in serial way, and it will become as output in a serial way at one bit at a time, and also extracted one bit at a time in sequential form. A serial in parallel out, which means data entered in serial way and output simultaneously in a parallel format once all bits are loaded. Parallel in serial out. Data is loaded into the register in a parallel way, like simultaneously all data are entered into flip-flops, but are shifted out one bit at a time serially. Parallel in parallel out. This condition allows simultaneously all inputs are taken by the register, and at a time the output of the data uh, shifted data is taken, acting primarily in temporary parallel storage. Visualizing shift register types. Understanding the flow of data, key to appreciating the function of each shift register type. SISO, data chain. Imagine data bits are as a queue. Each bit moves through a serial flip-flops or one after another. The flip-flop bit in the first bit out, but only after n data cycles, where n is the register length. And the next one is serial input, parallel output. Gathering of output. Data trickles in bit by bit in one bit by bit. Once the register is full, bits are presented at the output simultaneously, transforming a slow serial stream into a fast parallel burst. Beyond the basic types of registers, there are advanced types of shift registers uh, are existing. Beyond the basic type, advanced shift registers offer enhanced flexibility and capabilities for more complex digital system designs. Bidirectional shift registers. These registers provide the ability to shift data both to left and the right, controlled by an external signal. The bidirectional capability is crucial for applications requiring flexible data manipulation, such as in arithmetic units or data scrambling. And the next one is universal shift registers. Combining the features of bidirectional shifting with parallel loading capabilities, universal shifter registers are highly versatile. They can perform a wide range of operations, including serial load, parallel load, shift left, and shift right, making them adaptable to various computational tasks. And the third one is shift register counters. By feeding the output of a shift register back it into its inputs, specialized counters can be created. Examples including ring counter and Johnson counter, which are generated unique sequence of states and are used in timing circuits, state machines, and frequency dividers. There are some real-world applications for digital registers. Digital registers are not just theoretical constructs; they are all workers behind much of our modern technology, silently enabling complex operations like data storage in CPU. Central processing units heavily rely on registers to temporarily hold operands, memory addresses, and intermediate results during execution, ensuring rapid data access. And the next one is digital signal processing. Digital signal processing mainly rely on registers because the signal data will store in a temporary way in these registers. Digital signal processing applications use register for certain delay lines for each echo and reverb effects and performing specific arithmetic operations on sampled data, crucial for audio and video processing. And the third one is communication systems. In telecommunications, shift registers perform essential serial to parallel and parallel to serial conversions, facilitating efficient data transmission over various channels. And the fourth one is control systems. Registers are fundamental components in industrial control systems used in counters for sequencing operations and in state machines for managing complex system behaviors. Let's make a conclusion. Why digital registers matters? Registers for more than simple storage units. They are fundamental elements enabling the very fabric of digital technology. Uh, Fundamental data management. Registers provide fast, reliable mechanisms for data storage and dynamic movements underpinning all digital electronics and versatile operations. From basic data storage to complex shift operations, their adaptability drives capabilities in modern computing and communication. Third one is processing efficiency. Understanding registers unlock deeper insights into how digital systems efficiency process and manipulate information.